Professor Xu received his Ph.D. degree in traffic engineering from the Department of Civil and Environmental Engineering from UC-Irvine in 1997. He holds the chair professor in Department and Graduate Institute of Business Administration, National Taiwan University, Taiwan, and served as the advisory editor of Transportation Research Part E. And he was also the past editor-in-chief from 2013 to 2018. Professor Xu has published more than 100 papers, including 34 single author papers. His research covers intelligent transportation systems, intelligence logistics, emergency logistics, green supply chain management, business-to-business relationship marketing, quantum optical flow theory, and its applications in ITS, behavioral operations management, green marketing, applied science, and cognition in data science. He received appointed Outstanding Research Award, Ministry of Science and Technology from Taiwan in 2021, Outstanding Research Awards from Ministry of Science and Technology of Taiwan in 2006, 2012, and 2015. Dai-Yu Wu Outstanding Junior Research Award from National Science Council Taiwan in 2003. So without further ado, let's give a very big welcome to Professor Xu. Thank you very much.
Okay.
Yeah, stop share my screen. Yeah, thank you, Professor Xu.
Okay, so I should switch to here.
Yes. Great, perfect.
Okay, I have turned on my presentation materials. So from now on, it's my time. But first of all, I'd like to thank Hong Kong University for their kind invitation and organizing such a wonderful seminar for me and for us. Particularly, I would like to thank Professor George Huang, Yong Hong, and Ray, and all the colleagues there for your dedicated arrangement for this seminar. Actually, I know the some of my very good friends or students they also joining the seminar. But no matter who you are, I really appreciate all of you to join this seminar and let us have the very good opportunity to share each other about the research experience. Today, my presentation may cover two parts. First of all, I try to summarize some of my representative papers in the area, emergency logistics management. Particularly, I'd like to point out some challenges or the issues that required more efforts of us to dig into this area, because different from other research areas, the disaster management or emergency logistics management, they have the very unique objectives. Their objectives, one of the major objectives is to save the people's life, increasing the survival rate, and have our life value better and better, and so on. So, and also you may know, all of us, that we are faced with the COVID-19 pandemics around the world. So actually, we need to dig into such a valuable areas. So that's work and cooperate together to have our life better and better. So that's my motive to choose this subject to share with you. The second part of my presentation, I would like to talk a little bit about my research projects that I have just completed last year. Actually, this research project is just the topic here. It's about the proactive medical resource allocation and deployment toward intelligent disaster management. The motive for me to join this project, that's because this project was sponsored by the nonprofit organization. Actually, it's sort of like our National Disaster Management Center in Taiwan. And during the research, I'm allowed to use the real data or field data collected or provided by the center, because the research center, it can get access to the different public sectors or even the private sectors for collecting the data in relation to the disaster management. So I think that's a very wonderful and a valuable opportunity for me to join it. Actually, I'm the leader for these projects. Also, I would like to share with you some of the impressive output or outcomes from this research project. So that's my two of my purposes here. Okay, I would like to thank Yonghong's introduction. But as you may know, that I used to be the editor-in-chief for Journal Transportation Research Part E for 2 terms. And then I assigned the 2 co-editor-in-chiefs to succeed me to handle this journal. And one of them is my very good friend, Professor Jason Choi. Jason used to be the faculty member in the Hong Kong Poly U, but now you know that he has been my colleague at National Taiwan University. Up to now, I'm still serving for the journal as the advisory editor because I can share with the journal and all the editors and the reviewers my experience. In addition, I publish some special issues for the journal, particularly the special issue on emergency logistics management. Here you can see this special issue was published about 15 years ago. However, at that time, I think the whole world, the literature related to the emergency logistics is very, very rare. So that special issue has collected up to 7 pioneering works. So if you are interested, you can check out, because most of the research works there, they have received many citations. In addition, I serve for other journals as associate editors and EIB members. Okay, and these slides just give you the hints about my research areas. As Yonghong mentioned, actually, I was the very pure traffic engineering guy, because I took my Ph.D. from the University of California, Irvine, in the civil engineering, specializing in the traffic engineering. Also, my Ph.D. research is about the ITS, Intelligent Transportation Systems. But if you ask me if I'm still doing the research on the ITS, I may say yes, because recently I still have the paper published in the Transportation Research Part B. Particularly, I try to use the quantum mechanics or the quantum optical flow theory for use in automatic vehicle control and safety systems, sort of like autonomous driving vehicles. Recently, I also dig into the intelligent logistics. Last year, I got a paper published in POM. It's about the human and robot collaborative working systems. And also, I'm interested in the global logistics and supply chain management. Because the more and more recently, I just found that almost all the global business operations or the or strategies, almost influenced or determined by the upper level coming from the government, particularly the political power, political influence will have the impact on the business operations and so on. Here we have the 2 striking examples. The one is Belt and Road Initiative. The other one is China and US trade conflicts. So from these 2 examples, you're gonna see almost all the business, global business operations actually have been significantly influenced by the political power or political influences. So my research interest is that I'm taking those political uncertainties into account to deal with the operation management problem, logistic problem, or even the supply chain management problems. But today, I will put the highlight on the emergency logistics management. As what I mentioned, this area has a very unique objective or the research goal. So that I will mention that for more details. So let's start from the problem background. I think every one of us, we are living on the Earth. Unfortunately, up to now, we have the several global issues we are faced with in common. For example, we have the global warming issues, and that issue actually was caused by the carbon emission, air pollution, and so on. So actually, the global warming has had significant impacts on the whole or biosystem or even for the whole environments surrounding us. Also, we have the issue about the nature resource overconsumption. Particularly, we have the food issue there. We have the customer electronic products overconsumption. I think smartphones, that would be the striking example because the repurchase frequency for smartphones is very, very high around the world. And because of the second issue, we have the third issues. That's about the waste and the pollutions, particularly the electronic waste. More recently, we are encountering the fourth one. I think COVID-19 is the striking example. Currently, we still have the nightmare and in response to the COVID-19 outbreaks every day, anywhere. So I call that large-scale public health problems. In addition to these four, actually, we have to face the nature disasters or man-made disasters at any time, anywhere. According to the report from the United Nations, in the past centuries, we have the top 10 disasters. Unfortunately, there are more than 10 million people die because of the top 10 disasters. And among the top 10, 9 occurring in the Asia and 5 in China. And the top one is about the Great Flood that occurs in 1931. Millions of people died. So from those cases, that we may have the sense, actually we should work together, cooperate together to find out, figure out the strategies, solutions to cope with the disaster impacts on our life. Actually, in Taiwan, we have two major types of the disasters. We have the earthquakes and the typhoons that occurs every year. In Taiwan, Taiwanese people, we encounter, we have the experience of the Jiuh-Biing earthquake, or somebody called that the 921 earthquake because it occurs on the September 21st in 1999. This earthquake is very, it was really a nightmare because it occurs during the midnight. Almost all the people were sleeping. So even including myself, that we got so shocked because of disaster. This earthquake has a magnitude 7.0. Also, its location is not deep on the Earth. It's close to the surface of the Earth. So the disaster impact is very shock. It's very shock to anyone. Also, we have the typhoons, and particularly in 2009, we have the Typhoon Morocco. It's also the nightmare to us because during this disaster, almost 2/3 the area of Taiwan was flooded. And you will see here, there's a picture. This building, actually, it used to be the hotel. But during the Typhoon Morocco, the whole building collapsed on the river, so shocked. So actually, if you're interested or you used to conduct a research on the disaster management, and then you may face some challenges. According to my research experience, I think we have most of the challenges may come from the uncertainties because the whole disaster management actually is filled with uncertainties, different types of uncertainties. But here I try to classify the whole uncertainties into 4 categories. The first one, I call that the disaster uncertainties. Because we got the different types of disasters. For different types of disasters, that they have the different natures of the problems, different features of the disasters. Even if we have the advanced technologies, but we still have we still unable to predict where and when the disasters may occur. So I call that the disaster uncertainty. The second one is about the disaster impact. Almost, I think most of the nature disasters are large-scale disasters. That means the disaster impact, the scope is large-scale. So typically, you will see our infrastructure, hardware, software will be impacted by the disasters. Typically, it's hard to predict or to estimate the disaster impact on those infrastructure, hardware, and software. So, well, lots of challenges there. The other tools actually they refer to the supply uncertainties and demand uncertainties. Actually, these 2 types of uncertainties are also influenced by the first 2 uncertainties. The supply uncertainties refers to the uncertainties from the relieved supply side. If you are the government, if you are the decision makers of the disaster management, maybe you should consider the where your relief should come from, who can be your relief suppliers, and your cooperating mechanisms with those relief suppliers, because there is no way to have those relief suppliers just stand by there waiting for the occurrence of disasters and take actions. If you are doing things like that, then those relief suppliers are gonna suffering from the very huge inventory costs. Also, we have the uncertainties from the demand side. The demand side means the demands of the affected people or trapped people in the affected areas. Later, I will show you. Actually, we have some phenomena coming from the demand side. So you know, that will also influence the whole system performance or contribute to the challenges. Well, if you're interested in the disaster management research, or if you just start out to conduct the research in the related areas, you're gonna hear, almost all the scholars or researchers in this area, they will give you the hints. They will say, oh, take care of the disaster management cycle. Actually, before developing the models or the analysis, you have to make sure that the which phase you aim at. Actually, the whole disaster management cycle may contain 4 phases. They are the mitigation phase, preparation phase, response, and recovery phases. Actually, for each phase, because the features of the problems or the actions or strategies required can be different. So when you like to conduct a research on disaster management, first of all, you should make sure your research, which phase your research aim at, and then you can figure out further the strategies or the solutions. In addition, because we got the different types of disasters, basically we can classify all the disasters into 2 categories: slow onsets, such as typhoons, or the quick onset disasters, such as the earthquakes. Because the different types of of the disasters may contribute to the different disaster impacts and so on. That's all the things you should have to, you have to make sure before conducting the research on disaster management. Later, I will share with you some key issues that required further efforts in the research, according to my research experience. The first one is about the timeless of the release supply and the distribution. As what I mentioned, actually, all the actions about the release supply or distribution should be taken in a very short-term period, particularly if you consider to solve the problems for the emergency logistic management. Typically, we should consider completing all the action or decisions that should be made within the critical 3-day period. Here, the critical 3-day period means the 3 days within the 3 days after the occurrence of the disaster. Because typically we treat the critical 3 days period as the golden search and rescue period, because the well, that's image. You know, if you are the affected people or trapped people getting trapped after disaster, without food or water, or maybe you can survive just in 3 days. After 3 days, everyone's survival rate gonna be declined very sharply, and so your survival rate gonna be very, very low. So you give it a hint. All the decisions or actions should be taken within the 3 days. That's a crucial period. The second issue is about the resource management. Here from my slides, maybe you can see this. Well, you can see actually all the materials are shown here. They are the relief materials. This picture was taken 1 month after the Jiuh earthquake. The location was at the elementary school. Maybe you may ask, well, lots of the relief materials get merged there. That means those relief materials, they cannot be distributed very successfully or delivered successfully to the affected people, you know, during or even short term after the disaster. So, you know, the relief, particularly for the relief, the resource management is very crucial. Otherwise, all the relief materials turn to be the waste. The third one is about the accurate and real-time the relief demand information. I think relief demand information is the key for our modeling and analysis, because I think all the actions or decisions made for emergency logistics management should be the demand-driven. You know, basically you should know what can be the demand from the affected people. Unfortunately, you know, when you conduct a research on emergency logistics management, you always have such a challenge or experience. Well, you're gonna observe the relief demander can be the affected people. You know, the people getting trapped or in the affected area. Actually, they are the real demanders for the relief materials. Unfortunately, in most of the time, those affected people, they may not be able to report what they really need and when they need the relief the materials and where and so on. You know why? Because they just suffered from the disaster. So basically, the affected people's psychological or physical conditions turns to be unusual, not as normal as normal people. Hello, let me ask you a question here, or maybe you can think about that. You know, according to the United Nations, their reports, please guess what kind of relief material has the highest priority for the delivery to the affected people? I mean, what kind of relief material is the most urgently needed by the affected people? When I have the physical meeting or physical conference, each time when I ask the same question to the audience, most of the answers may be the food or the water or even the sleeping bags and so on, but actually not. They are not the exact answer. You know, according to the report of the UN, the material, relief material with the highest priority is milk. Milk. You know, because maybe most of you forgot, for those affected people, some people, they are fragile. They are so weak. For example, the elder peoples, the young children, the babies, newborn babies. You know, if you just deliver the lunchbox, the meal, those the newborn baby, they cannot have it. You know, even the young children, they cannot have it. So actually, you know, for example, the Sichuan earthquake, you know, according to my research, historical data showing that hundreds of the newborn baby, including the young children, died in the Sichuan earthquake because of no food, no milk. Okay, so actually here, just give you the example. Actually, we are encountering the relief demand phenomenon. The relief demander actually refer to the affected people. However, they may not be able to report the real demand. So in most of the cases, the relief demand information may come from other sources. They may be the on-spot reporters, the local governments, or local search and rescue teams. They will report the relief demand on behalf of the affected people. But actually, you're gonna see they're gonna be the gap between the relief demand and the reported relief demand. So we always have the bias there, you know, because of the phenomenon. So for example, if you're the government, you are decision makers of the emergency logistics management. Even if you receive the relief demand information from different sources, but unfortunately, those sources, their degree of reliability may not be the same. So how to deal with the multiple sources information, how to estimate the real demand to meet the requirement, meet the real demand of the affected people. Okay, that's a challenge in there. That's a challenge in there. Okay, because of those challenges or the issues, I used to propose the architecture for the development of intelligent disaster management systems. Actually, I proposed that the system should have the 2 layers. For each layers may contain several subsystems. For example, we may need a fundamental layer. This layer may need to contain 3 subsystems there. The first one is about the subsystem to deal with the disaster forecast or the disaster impact analysis. And also we need the subsystem to cope with the disaster-induced traffic and logistic demand forecasting, because that's the base for our actions and for our decisions for the disaster management. Also, we need the subsystem to deal with the disaster-induced survival behavior analysis. As what I mentioned, our demanders refers to the affected people. Unfortunately, their psychological or behavior phenomenon can be different from the normal situations of the normal people. So we need to have some models or the approaches to analyze those affected people's psychological or behavior conditions, situations, or even the emotional responses. And once we build up the fundamental there, then we also need to have the application there to contain the 4 subsystems here. For example, we need to have the emergency traffic and logistic information system. Well, if you are familiar with the business logistics, maybe you have the ideas about how to build up the architecture for business logistics. Because from the textbooks, we have the architectures for the logistic information systems, right? But actually, even if we have the ideas about the logistic information systems, that only applicable for the normal business operations or business logistics or supply chain management. However, we may not have enough ideas or knowledge to develop the logistic information systems for the use of the emergency logistics or disaster management and so on. Also, we need a subsystem for the emergency supply chain management. For example, now we are encountering the COVID-19. I'm not so sure that what happened in Hong Kong, but actually currently in Taiwan, we need vaccines. We need medical care devices to test whether or not you are confirmed and so on. But actually now the people here, we have the panic to buy those devices. I think a similar experience may occur in Hong Kong. So we may need the strategies, the approaches that for the emergency supply chains management and so on. The third one is about the emergency search and rescue approaches or mechanism. I think that's the core function because it's very important to save the trapped people's life, okay, to rescue the trapped people. Finally, I think we need to build up the emergency traffic network management system. We need a subsystem to couple with this. For example, in the United States, they may have the disasters such as the hurricanes every year, particularly in the southern United States. In Miami, as I know, each time when they encountered hurricanes coming, millions of vehicles may move together or simultaneously on the freeway systems. So you can see almost all the freeway systems got blocked, got bottlenecks at any time, anywhere there. So actually we need a subsystem to deal with that kind of situations. In the following, I just show you some of my representative papers for the emergency logistics management. This one, actually, this paper has been published in the Transportation Research Part B. In this research, we try to integrate the 3 types of network. For example, during or after disasters, you will see some of the affected people were moved from the affected areas to the refugee centers or the somewhere safer. So there's evacuation network or shelter network there. So we need to take it into account. The second type of network is about the medical supply network, because during or after disasters, you're gonna see the medical resources should be distributed from some origins to the destinations. So actually, we need the network to deal with that kind of phenomenon. Also, we need to take into account the relieve the supply network to couple with the daily use, the commodity distribution, supply, and so on. However, you will see we just have the one traffic network. However, during or after disaster, we have the we need to use the same traffic network to achieve the different purposes. So that's a challenge there. And in these papers, we adopt model objective programming to solve the problem. Particularly, I think one of the features is that we take into account the psychological cost of the affected people. The psychological cost here is sort of like the feelings or emotional responses of the affected people when their demands cannot be satisfied. For example, if you're affected people and maybe you need 2 units of the water, but finally you just get 1 unit of water, then what happened? Your demand cannot be satisfied. Then you got angry, you got panic, you have the stress, anxieties, and so on. You worry so much about that. That's all kinds of the psychological cost. So here we try to quantify such emotional responses and take those into account in the model development. The second representative paper is about the relief supplier selection or cooperation. As what I mentioned, if you are the governments or you are decision makers of the emergency logistic management, you may need relief suppliers to help you for the relief supply or to provide humanitarian logistics services. The thing is, you may not have the idea about where and when and which one can be the more reliable. Also, it's no way, even if you have an idea about who can be your relief suppliers to cooperate with. However, you may not have the ideas, or it's no way to ask those suppliers just stand by there and waiting for the occurrence of the disasters, because that will contribute to the very huge inventory cost and so on. So basically, you need to have the very well designed cooperative mechanism used for the relief supplier selection, cooperation, or coordination, and so on. So that's the second paper we used to deal with. The third one, I think, is the new idea there, some new ideas, because we proposed so-called self-organized emergency logistic mobilization. In this paper, I think the distinctive feature is typically, if you check out almost all the literature on the emergency logistics or disaster management, you can find out decision makers in the literature actually they can be the governments or the non-profit organizations. Those decision makers, they locate outside affected areas. However, here in this paper, we claim that that affected people to be the decision makers themselves. What I mean? Well, actually, here we promote these ideas. You know, after the disasters, actually we can have the affected people to organize, self-organizing as the volunteers groups, or actually the affected people they can join and different groups of volunteers. Here, at least we promote 3 types of volunteers. For example, one volunteers can be in charge of the medical care services, because in the affected areas, some affected people they may have the medical care expertise professionals. For example, they may be the doctors or nurses. So after disasters, those affected people they can join as the volunteers in this group. The second group can be in charge of the search and rescue. For example, among those affected people, some may be the young and strong and normal people. So they are encouraged to join this group in charge of the searching and rescue. Also, we need a third group of volunteers in charge of delivering daily use commodities. For example, your neighborhoods or even your family members, you are willing, then you can do that. Because after disasters, I think either your family members or your neighborhoods may the best known what you really need, particularly for those daily use commodities. So actually, in this paper, we promote these ideas that affected people be the decision maker themselves. Actually, affected people can help themselves. They can self-organize and join the different groups of the volunteers, and they can take actions before the arrivals of the outside acts. Okay, so there's always a time difference between the disaster occurrence and the arrivals of the outside relief supplies. So I think here in this paper, we promote the new ideas. So if this is the case, then but we still have some uncertainties there. For example, we may not have the ideas about the number of the affected people that are willing to join in it, the volunteers. So the number of volunteers could be with uncertainties. Also, even if we know the number of the volunteers, but please guess, if you're the volunteers, you are affected people, and maybe your own psychological and physical conditions may not be as usual or as normal people. So actually your performance, your perception, your attitudes could be different from the normal people. So for example, if you are the volunteers and you join in the search and rescue team, but what you observe are many died bodies, what happened to yourself? Well, you maybe you got shock, you got the anxiety, you have some panic, you have stress. So also because the volunteers, basically they are just volunteers. They may not be the fully professional or search and rescue teams themselves. So actually, we still have some uncertainties there. So if this is the case, then what kinds of methodology or what kind of model that can be used to carry out this so-called self-organized mobilization for the affected people? Also, I have another paper. It's also noteworthy because in that paper, I tried to take into account the survival resistance. I try to maximize the survival resistance because I think that's the key each time when we make the decisions for emergency logistics. Unfortunately, even if you like to maximize survival resistance, it's hard to quantify this. So I try to conduct an empirical study to figure out or explore key factors, or even I try to build up the hypothesis. Particularly here, we have that one hypothesis. We link the survival attitude to the survival resistance. For example, if the survival has a good attitude about the government's performance for relief supply, distribution, or the logistic service and so on. If the survival attitude is good, then it's positively associated with the survival resistance. Just like you can imagine if you are the person with the sickness, you got sickness, and but if your doctor tell you, oh, okay, no problem, you can recover very early. Oh, it's no problem for your sickness. Then you got a very good attitude. Then that will give you the very good effect on for your recovery, right? So actually, the attitudes of the survivors is positively associated with the resistance. So once we can estimate the survival attitudes, like a theta here, then we can link it to the survival resistance. So let me further use this slide for details introduction. As image, if you are the affected people, during or after disasters, maybe you may perceive the disaster impact. Also, you may get some information from your close friends or your relatives from the other sources. Also, you may get the information or message from your neighborhoods. Okay, all the information, I call that the environmental information, they gonna contribute to your affective response, like your emotions, during or after disaster, because of the environmental information. Simultaneously, meanwhile, you also perceive the performance of your governments or the decision makers in terms of the relief distribution or the logistic services. For example, if you stay in Hong Kong, if you stay in Taiwan during the COVID-19 outbreaks, maybe you can perceive that, okay, the government's performance, just like us. So you may have some effects on your rational cognition, and you have some effect on your affective cognition. So all of this will contribute to your attitude, like a theta here. So actually, we have the model to estimate the theta value and then aggregate. Then we take this aggregate the theta value into the objective function. So it represents the objective on the demand side, right? So our purpose, one of the major purposes, is to maximize the survival resistance. On the other hand, we first consider so-called emotional contention here, because if you are affected people and you perceive you have some attitudes, somewhat your attitudes or your perception will influence others. So that will contribute to the emotional contention, and particularly under the negative emotions, such as emotional contentions, the propagation speed will be very high, and so on. That means that affected people will influence each other very quickly, particularly under the negative emotions. So we take this into account to build up the model and then to solve the problems. So that's all for my presentation for the first part. In the following, I'd like to share with you my research projects. As I mentioned, I just completed this year. Actually, this research project was sponsored by our National Disaster Management Center. In that center, they have the disaster information platform called TERIA. Okay, because of this research, so I'm allowed to use the data collected from this information center. I think if you used to conduct the research on emergency logistics or disaster management, you may have the similar experience. It's really hard to collect the real data or field data from the affected people. Okay, but actually they are required. Otherwise, if you just use the artificial data or simulation data, I think finally it turns to be just for academic use, not for the practical use. So because of this valuable opportunity, I'm allowed to use the real data. So I'm the leader for these projects. So for the whole project, we consider to have the 3 subjects to investigate. First of all, we try to build up a so-called cluster-based disaster risk analysis model. For example, here you can see this is the whole Taiwan area. So in the Taiwan area, we first divided it into the several regions, or I call that the clusters. So we developed the methodologies to estimate the disaster risk associated with each clusters here. The thing is, don't forget, I mentioned here in Taiwan, we have the earthquakes, we have the typhoons. One is slow onset, one is quick onset. And these 2 types of disasters, they have the different features of the problem, or features of the disaster impacts. So we need to figure out the way to estimate the disaster risk. Or once we estimate the cluster-based disaster risk for each regions, then it's easier for us to identify which region could be critical. The critical region means the region with the highest disaster risk. So we can further aim at that critical regions for further analysis. For example, in the second subject, we developed a methodology to estimate the traffic network connectivity or vulnerability for that study site, for that region. And then we further build up the methodology to cope with the medical resource allocation and deployment. I think that the third subject depends on the outputs of the first one and the second one subjects outputs. Okay, but if you have the literature and you review the related literature, I think there's a very weak point there. I think in most of the literatures, when they build up the models or they conduct analysis or they figure out the strategies for disaster management, basically they assume the traffic network is perfect or is as normal as non-disaster occurrence. But actually, for each type, for different disasters associated with the different disaster impacts, our traffic network, the infrastructures, including the hardware, software, actually can be damaged to somewhat a certain extent. So we need to take those into account. Okay. So actually, in the whole project, we have the 3 key modules. So for each modules, we embed a specific methodology to deal with that. For the first one, as what I mentioned, used to analyze the region-wide disaster risk. So here we need the input. The input includes the data, the real data or field data in terms of the disaster information or the geographic data, socio-economic data, and so on, or even the road conditions. And the methodology we propose here basically is based on the Markov chain random field calligraphy. Actually, it's kind of the space-based data mining technology. For example, here we consider typhoon and earthquakes, particularly for typhoon. We need weather information collected from the weather stations. However, the weather stations, the number of weather stations in Taiwan, they may not be enough. Okay, we may just have a very limited number of the weather stations to collect the weather condition, weather information. So I call that the point data. However, when you just have the point data, how to extend to use the point data for the network-wide estimation, then we need to have the other strategies or methodologies. So that's the reason we use the Markov chain, the random field calligraphy to deal with that kind of problems. And then we have the output from the module 1. It's about the vulnerability or connectivity of the traffic network, and so on. So this is the example of the output from the module 1. Maybe we can check out the figure on the right-hand side. Here you can see the whole Taiwan area. Actually, some regions are indicated with the dark blue, but some regions are with the light blues. The dark blues means the regions that have the higher or highest disaster risk, and so on. So basically, we have all the output of visualization. Okay, and then it's easier for us to identify which regions can be the critical regions for further solutions. So, and once we identify the critical regions, then we go to the module 2. We build up the methodologies to analyze the traffic network connectivity for that critical regions. So here we have the several output expected. For example, we may have the output in terms of the traffic network connectivity. Later, I will show you the results. Also, we have the output about the bottlenecks, especially for the road bottlenecks. Road bottlenecks means the critical links or critical arcs on the traffic network. Also, we have the isolated areas. Isolated areas, actually, they refer to the critical nodes. Critical nodes may associate the connectivity can be very, very low or close to zero or something like that. So we have the methodology of, for example, as what I mentioned, actually the disaster management center, they have the information platform to provide the real data. For example, we receive the real data in terms of the permanent ground deformation, called the PGD. Actually, PGD is the popular terminology used in civil engineering or the construction, the engineering, and so on. And actually, here it can be treated as the index about the link damage. Okay, so we can have the X value, the PGD value from the information center, and then we can input the X value into the above the equation, and then to estimate the fragility curve. Is a link-based fragility curve. Actually, in this research, we have the several curves for the link-based fragility. So, for example, if the disaster risk is very high, then we can check out, for example, the blue curve, and then we can have the PGD value, and then associate the PGD value with the p-value of the percolation theory. Okay, here, let me give you the explanation. Even if we have the PGD value for the link-based damage situation, but not just a link-based situation or link-based fragility, we need another methodology to build up the association of the link-based damage with the network-wide connectivity or network-wide vulnerability. So here we apply the percolation theory. Actually, percolation theory has been developed and widely used in some other areas, such as the communication, to analyze the communication network or the information technologies and so on. For example, if the communication network, some arcs or links, they can be broken. So they will gonna influence the whole communication performance or quality or something like that. So we apply the percolation theory, or even we further build up the association between the PGD and the P value. So here, P value actually is the critical parameter in the percolation theory. The lower the P value means the lower connectivity of the traffic network. The higher value of the P represent the higher connectivity of the whole traffic network. So once we have the real data about the PGD value, it's about the link damage, then we can further analyze or estimate the network-wide connectivity conditions or the vulnerability, something like that. So let me show you the example from the output of the model 1. So this is a case when the p-value is equal to 1. Okay, the p-value is bounded by 0 and 1. So the p is equal to 1 means the whole traffic network is perfect without the influence of the disaster impact. So let's see, once the p-value decrease, and then let's see what happened on the traffic network. So this is a case for p equal to the 0.7, 0.5, even for 0.3. So let's show you again. So this is a perfect traffic network. So when the p-value increase, then you're gonna see the whole traffic network gonna be broken into the several subnetworks. So you will see when we consider using the traffic network for emergency logistic management or disaster management, actually the whole infrastructure actually had been influenced or damaged by the different disaster scenarios. The thing is, can we take this into account, because it's a kind of the uncertainty from disaster impact. Fortunately, because we have the real data, also we have the very robust methodology to use. So we can further figure out what happened on the traffic network. So this is the case, okay? Once the earthquake with the magnitude 7.0 occurs on the study site, okay, actually we select the Tainan city as our study site. The Tainan city locates in southern Taiwan. So under the earthquake with the magnitude 7.0 is a very nightmare earthquake. You're gonna see the whole city will be broken into the subnetwork. I mean, in terms of traffic network. The network with the biggest one is the red one. However, don't forget we have the very small network, like the tense network here. So actually, the tense network is we call that isolated network. So here, let's see. When the magnitude of the earthquake, the change, increased from 5.0 to 7.5, you're gonna see the whole traffic network change in terms of their connectivity. So when the disaster impact increase, you're gonna see the whole traffic network or infrastructure will be significantly damaged. So, and in addition to the traffic network connectivity, we further figure out or find out the second type of output. It's about the road bottlenecks. For example, here, okay, here is based on the, we have this idea. Let me ask you the quick questions. I believe the some of my audience or the most of my audience may ever see the movie, a Marvel movie called Adventure Endgame, right? In that movie, there was a scene. Dr. Strange just give a hint to the Iron Man about how to beat Thanos, and finally, the Dr. Strange just choose the best solution based on simulating billions scenarios, right? And then that Dr. Strange choose the best one. So similar, we just take the similar ideas. Even if we have the idea about the traffic network connectivity, but we try to take into account well, the different disaster scenarios. We simulate it again and again. And then we try to explore to find out the road bottlenecks there as the critical arcs or critical links. So once the critical links are identified, that means that, okay, if you're a government, then you are suggested to make a more investment for the proactive disaster management or something like that. And the third type of output is we call that the isolated areas. Isolated areas actually refers to the critical nodes because after the disasters, some sub areas or some nodes they may lose the connectivity. Okay, maybe all the roads connecting outside areas can be broken or damaged. So that will have the sub areas be the isolated areas without the connection, without the access to the outside resources, particularly the medical resources. So using our methodology, we can further identify where can be the isolated areas or where can be the locations once we take into account the different scenarios of the disasters. So that will be easier for us to take actions for further proactive disaster management, for example, investment or something like that. So this is the example. We have the output visualization. So actually you can see here different color means that different probability to be the isolated area. So based on our output, we can easily identify maybe the sub area here could be easier because that they have the highest probability to be broken and to be isolated. And if we first zoom in, then we can see, oh, that the isolated areas may look like this. So that's all the output. And we further have the output, the visualization from the research projects. Okay, and then we have the module 3 is about the proactive medical resource allocation. Here we use the bi-level stochastic model. In the upper level, we consider to minimize the total social cost. That contains the emergency cost on the supply side and the deprivation cost on the demand side. And the low level contains the minimizing the deprivation cost on the demand side. And then we use the real data and the output from the module 1 and 2, and then we further generate output from the module 3. So this is a case. In a study, at a study site, we consider 36 hospitals as our locations for the medical resource allocation and deployment. And there we consider 3 types of the medical resources. They are water and biotechs and hospital beds. And then using our models, and then we found out the optimal solutions for these 3 types of the medical resources. So these are the numerical results there. So finally, this is I promise this is my last slide to share with you. So basically, maybe you can capture my ideas. Because now we are further moving to the epoch industry 4.0. So when we move to the industry 4.0, you may imagine we may get more and more the advanced technologies, or we call that the disruptive technologies. However, those disruptive technologies, so-called disruptive technologies, they may just be applicable for use of the normal business operations or the logistics or supply chain management. I think there's any opportunity to apply those disruptive technologies for so-called intelligent disaster management. For example, here we may have the technologies for use of big data, or to collect data from the multiple sources. So I call that sensory there. So is it possible to use that kind of data collected from the disruptive technologies for further use of the disaster forecast or disaster impact prediction and so on? And then even we have the there for computing. I call that a computing there. We have some disruptive technologies, such as the artificial intelligence, cloud computing, or even we have the quantum computing. So can we use these disruptive technologies for the further emerging transportation or logistic demand forecasting? because the computation, the process, it takes time. So we need the advanced technologies to have the computation very efficient. And also we have there called automation there. We have the several technologies. For example, we have the autonomous vehicles. We have drones. We have the robots, cobots. For example, currently we have some research, including one of my papers published in Transportation Research Part B. We try to integrate trucks with the drones for the VRP, vehicle routing problems. But even if it is workable, but not just for the normal business operations or for the business logistics, but is it possible to apply those disruptive technologies for the intelligence relief distributions or the intelligent search and rescue? For example, because as I just showed you, after disasters, maybe we have the isolated areas. For those isolated areas, that means all the roadways or the links, they can be damaged. So the connectivity for the isolated areas could be very, very low or even zero. So even if you use the trucks, it may not be so easier to relieve the materials to meet the demands of the affected people in the isolated areas. So is it possible to use the drones or even the autonomous vehicles or robots, or even for the search and rescue? Is it possible to use the robots to help us to search and rescue the trapped people, something like that? So I think all these research ideas, some of them are on the way because currently I'm still leading some of my research teams digging into some research on the intelligent disaster management. I think because currently we are faced with the COVID-19, even we can consider how to apply those disruptive technologies to reduce the disaster impacts. So basically, I really hope that my presentation today can stimulate more researchers to dig into the related areas. Thank you so much for your listening. That's all my presentation.
So thank you very much, Professor Xu, for the very insightful presentation. We learned a lot about disaster management. So for all the participants, if you are interested in asking questions, so feel free to use the Q&A function. And then we'll ask a question on behalf of you. When you ask a question, please also leave your affiliation and also name in your question. I think we received some question in the Q&A box. So we have the first question. Professor Xu, thanks for your inspiring talk. So this is David from Hong Kong U. So he thinks that in addition to the very complicated system structure to optimize the operations during the disaster, he thinks another challenge is the uncertainty in disaster management. Typically, outcomes of disaster can be quite different each time in terms of, let's say, the seasons, lengths, locations, and severities of the disaster. Frequencies of disaster are quite low compared to other logistics problems. How can we model uncertainty?
Okay. As what I just mentioned in my presentation, actually, we got lots of the uncertainties to cope with the disaster management, especially if we consider the intelligent disaster management. But here, as what I mentioned, actually, when we consider disaster management, actually, we may need to first take into account there's a cycle there. There are 4 phases: mitigation, preparation, response, and recovery. Well, currently, I think because it's not so easy to predict the disaster occurrence, when and where and so on. But I think the initial step or the first step, I suggest maybe we can build up some methodologies for analyzing the disaster risk just like what I mentioned for the subject 1 or module 1. Here we try to divide the whole Taiwan area into the several regions. And for each region, we use the methodology proposed to estimate disaster risk. So once we have the ideas, have the knowledge about the disaster risk associated with the regions, then we can give the suggestions to our decision makers, including our governments. Oh, maybe those are critical regions that deserve the more investment or the more efforts. Maybe we can take some actions in advance, not just waiting there for the occurrence of disaster. I think maybe we can aim at the mitigation phase first, and then once that the strategies or methodologies are built enough or very solid or reliable, we can further consider the methodology or strategies for the preparedness or even for the response. Because when we consider the strategies or methodology for response phase, that means the model, typically we need the operational model. So all the models, they should be processed. The computation should be taken even in real time. So very urgent. So we may need a more advanced technology for that. But actually, we can move toward the automatic goal, intelligent disaster management, step by step. I'm not saying that simultaneously we should solve all the problems for all these 4 phases, but actually we can dig into those problems and try to figure out the appropriate solutions. Don't forget, even if we take the very little step, that could be the critical step for the intelligent disaster management. Okay, if every one of us, especially the scholars or researchers in the areas of the logistics, supply chain management, or even the operation management, if we are willing to dig into this area, I'm not saying that you should put all your time, your energy, your resources in this area, but if you like to share, take just a part of time, your energy for this such a meaningful, valuable research area, I think someday, we're gonna move up to the final step. We're gonna reach our automatic goal for the intelligent disaster management. That's my point there.
Yes. Thank you very much, Professor Xu. I guess, David has a follow-up question. So how can operations research techniques help, for example, robust optimization? Mm-hmm. Yeah, so this is his question, yeah.
Okay, actually the last slide, I just stop here. Actually the last slide, actually some of the ideas, they are quite new. But even if when you check out the related literature, I think the related literature is very, very little, very, very rare. In terms of the use of the automation technologies for IDM, I think my initial idea is because I have some papers published in terms of the human collaborative with the robots. Let's see if you are the search and rescue team members, and for the normal situations, when you like to take the mission, search and rescue, maybe all your teammates can be just the human search and rescue teammates. But here, I just consider, is it possible to have the robots, or is it possible to develop so-called the cobots, work together with the search and rescue teams? Not just search and rescue, but also protect the search and rescue team members' safety or something like that. Increasing the safety and so on. And then that will be very helpful for the intelligence, so-called intelligent search and rescue. Or I just consider, from the research output, currently we can identify the isolated areas. But in Taiwan, some isolated areas, they locate in the top of mountain. And, very few people living there. So no way we drive cars up to there. So we just think, okay, is it possible to utilizing the robots or even, let's think about that. We just consider this case. At the beginning, we drive the trucks loading the drones, okay, and then for the last mile delivery to the isolated area, we use drones. We use drones. If this is the case, what happened? What's the problem? See, when we are doing the vehicle routing problems, the link length or link travel time typically either you can assume it's deterministic or is a stochastic. But because the whole problem background is the disaster, after disasters. So even if you drive the cars, moving so close to the isolated areas, but nobody knows how far, how long you can drive your car, you can drive your trucks to close to the isolated area. Nobody knows what's the distance for your last mile. Okay, the last mile associated with each isolated area actually is different and with uncertainties. And then we should further figure out if we use the drones to deliver the relieve the materials to the affected areas. And is there any distance limitation? I mean, because the battery, the drones need a battery, need to be recharged. So actually, we got some challenging problems there. But actually, because we have some challenges, we have some difficulty to solve. That's our research contribution. That's also our research value. So if you are really interested in that, and if you are the guy very good at, let's say, vehicle routing problems or logistic problems, then you can join. Okay, you can dig into this. Think about that. Last mile delivery for the isolated areas. See? Yeah.
Thank you very much, Professor Xu. So for others, so if you have questions, so feel free to use the Q&A box. So maybe I would like to take the privilege to ask. Oh, finally, you have a question. Yeah, please, you first. Yeah, please.
Yeah. Okay. Thank you.
Please. Yeah.
Yes. Thank you very much, Professor Xu, for your very insightful talk. And I have a quick question. I'm thinking of you have talked about very important aspects of disaster management, which may deal with very severe disaster. Mm-hmm. And we in real life we also encounter many less severe incidents or events, which is more often to occur. So I'm thinking of another. So your research deals with detection of isolated area and also the distribution of relief. So it's the inward direction. I'm thinking of that. On the other direction, in the reverse direction, we have evacuation of human beings. Mm-hmm. I just want to have your suggestion if we are considering these both directions, inward direction of logistics and outward direction of evacuation. How can we model and consider this type of problem? Thank you.
Okay. Yeah, that's a very good question. Actually, what you mentioned about is the when we consider the disaster management or what I call the emergency logistics management, actually, originally I have a slide to show you overall the related literature. I put all the related literature in the slide, but because of time, I didn't show it today. Actually, when we conduct the research on the emergency logistics management or disaster management, first of all, it also depends on where your actions or decision are made. You know, if the action or decision are made outside the affected area, then we have the emergency logistics or emergency relief supply chain management and so on. If the actions or the decisions are made within the affected area, then we have the reverse emergency logistics management or some other something like that. For example, when I said reverse emergency logistics, that means, you know, after the disasters, typically you're gonna see maybe the dead body or the I mean the dead body including the animals bodies, something like that, or plants bodies. You're gonna see all the dead body that sprayed in the affected area. So it's very crucial to move out those waste or dead body out of the affected area. Otherwise, it will contribute to the more serious health problem. So that kind of problems or that kind of solution, typically we were positioning as the reverse emergency logistics. Don't forget, I used to show the one slide and tell you actually we have the 4 phases. Actually, there's a phase called the recovery phase. What you mentioned when we consider the reverse emergency logistics, actually the problems itself or the solutions or the strategies applied to the recovery phase. So that's what I mentioned. You know, when you conduct a research, first of all, you should figure out, or you should determine, check out which phase I am at. Okay, and then I'm in that phase, and then further figure out your solutions or your modeling and so on. Currently, it's hard to integrate the forward emergency logistics and reverse emergency logistics. For example, if you drive a truck, and for the forward emergency logistics to deliver the daily use relief, like food, water, and so on. And when you consider, okay, when you came back from the affected area, and you consider move out the dead bodies, I think sometimes it may not be agreeable, because the daily use, the commodity is a normal food, water, and so on. But when you use the same trucks, use the same vehicles, but you are loading dead bodies, I think most of people, they may not agree with that. So typically, sometimes when we think, that's a good idea to have the integration, but I still suggest maybe we need to figure out specific solutions or strategies to deal with either the forward or reverse emergency logistics. That's my suggestion.
Thank you.
But your question is very good. It's very good. Yeah, very good. Yeah.
Thank you very much, Professor Xu, and also Fanny. I think time is running out. We have perhaps the final question from the Q&A box. From Shen Wen-Shan, a postdoctoral from Beihang University. Thanks, Professor Xu. Drones can provide non-contact deliveries, particularly during COVID-19. So could you please talk about some new logistics applications of drones or unmanned vehicles for intelligent disaster management? Yeah.
Oh, okay. Yeah, the guy you just mentioned, he's my student. Okay, he's my student. And we just have the paper published in Part B this year. Long time no see to Xiao Pang. I call that Xiao Pang, you know. Sorry about that. Currently I have the updated research where we just considering the whole problem background is for the COVID-19. For the COVID-19, because it's about a large-scale public health problem. Also, some of the problems maybe come from the features of the epidemics. Okay, so currently, I just try to develop the models to estimate or even to project how the epidemic widespread, the spread. About particularly, I try to build up the model to estimate the speed of the shock waves, caused by the COVID-19 virus. Because currently maybe we just have the ideas. In Taiwan, we may have the idea about the locations or the hotspots for the confirmed people. For example, such as the communities. For some buildings, for some communities, there are many confirmed people there. Okay, and then we need a methodology or model to project the shock waves, the speed of shock waves, how such a pandemic they got by influence the neighboring areas or something like that. Because don't forget, today I mentioned one methodology. I call that Markov chain random field triggering. Why we use that kind of technology or methodology to solve the problem? That's because when we divide the whole Taiwan area into several sub-areas, we found out for some disasters, such as the COVID-19, the sub-areas or sub-regions, the impacts, they will influence each other. Okay, so actually, for the first step, we need a methodology to project the shock waves, like a shock wave behavior of the virus, and based on either the big data technologies or the computing and so on, just like what I mentioned. After going through the millions or billions disaster scenarios, and then you may be able to choose the best solution, the best way to cope with that. So that's my suggestion. But I think the last question is good. But under the table after the conference, I think I will ask Xiaopang to contact me for further details. Okay, thank you, Jiuh-Biing, for your question.
Yeah, thank you, Professor Xu. I think, time is almost up. So one thing I forgot to mention, Professor Huang, so he is currently out of town, so he apologized. He is unable to attend this your seminar because of his duties. But he welcomes you, so he looks forward to welcoming you to Hong Kong U. So now I would like to invite our Director of Research, Dr. Ray Jung, to give a closing remark on behalf of the department. Yes.
Mm-hmm. Okay. Thank you, Yong-Hong. And thank you so much, Professor Xu, for the comprehensive and insightful talk. I learned a lot, even though I don't have the research areas covering the disaster management. So in the intelligent disaster management system, Professor Xu talked about the technical, theoretical, and practical aspects, which could be useful for all the participants if you are interested in this research domain. And on behalf of the department, I would like to thank the great support from Professor Xu, and especially the acknowledgement for the participants for looking at the leader series seminar. So this is some words, and thank you for the great work from the organizational team, Dr. Guo.